So, where is my key? Let's go over the answers as soon as I can find my key. I want another one of these. I want a File Explorer. Where are you, File Explorer? Boom. I want the answer to this one. Come here. Do I have it? Nope, I totally don't. Where are you? Or do I have to do them all myself? I guess I can do it all myself. Nope, not there. Let's crank them out. Okay, so this first, let's see how fast I can do this. This is going to be, ooh, that's a terrible color. 63 over 10, which can't actually be reduced. I don't think. 63 over 10, this is going to be 4/10, which is 2/5. This one's going to be 5 over 1 times 3 over 10, which is going to be 15 over 10, which is the same thing as 3 over 2. We're going to get 32 over 70. Wow, that's terrible. I should have cross-simplified this. That's going to become a 2. That's going to become a 5. That's as much simplifying as I can do, which would have made this thing 16 over 35. This one would have been 5 over 8 times 1 over 6. There is no cross-simplifying to happen there. Just let them walk in and sit down. Nobody needs to make a comment. 5/8. We're going to cross-simplify here. This is going to become 11 over 6 times 7 over 1, because I can divide each of those by 2. This is going to become 77 over 6. Flip the page. This is going to become 2/5 times 12 over 3, which I can, I can simplify this. 12 over 3 is what? Sorry? 4 over 1. Divide top and bottom by 3. It's going to become a 4. That's going to become a 1. So this is going to be 8/5. No, yes, excellent. Now I'm going to have 9 over 2 times 5 times 2 is 10. That's going to be 5 over 14. There is nothing to reduce. So this is just going to become 45 over 28. If you got something different than I got, again, I'm doing this very quickly, as you can see, so don't assume that I'm not making mistakes. If there's something you'd like me to look at in more detail, let me know. This should be 14/5 times 13/12. I can reduce here. I'm going to cross-simplify these guys. Divide by 2, divide by 2. That's going to make that a 7 and that a 6. Oh boy, 7/13 is 91 over 30. Did I do that right? 7 times 10 is 70, 7 times 3 is 21, 70 and 21 is 91. Done, okay? This is going to be a half times, I can reduce this right away. Divide top and bottom by 3. I'm going to make that 1 over 4, and then I'm going to multiply this by, well, it's going to become 12 over 3, which is 4 over 1. Oh, and then I can reduce that. This is just a half. Love that. This is going to become 10/3 times 14/10 times 1 over 7. I can make some simplifications here. Oh, look, I can divide both of those by 10, giving me a 1 and a 1. I can divide both of those by 7, giving me a 2 and a 1. And now when I multiply across the top and multiply across the bottom, I get 2/3. And then this one, I'm going to get 6 over 1 times 4 over 3 times 3 over 8. I can make some cross simplifications here to make my life a little easier. These two are both divisible by 3, making that a 1 and a 1. These two are both divisible by 4, making this a 1 and a 2, and then I can actually cross simplify again, or I could just do the math. 6 times 1 times 1 is 6, 1 times 1 times 2 is 2, 6 over 2 is 3, and we're done. So that is the homework. Please tell me I hit record. I definitely did. Love it. That is the homework I wanted you guys to do yesterday. The questions on any of that? Does anyone want to object to any of the questions that I did? Bill Cron, you're on the wrong page. Should at least be checking the work I gave you. Hey, you found your binder. Excellent. So, there it is. If you need more practice out of there, and as you're getting ready to do your test, obviously a great thing to do is go back and do the odds. I have not done the odds. I can provide you the answers to the odds, should you choose to do them. But today we're going to crank out 2 more things. This is just a review on how negatives impact fractions. And I might actually crank out, might get you guys today to do, do I start this? We might start this today too. Bed mass, and now we're going to bring the fractions into the bed mass, which is going to be great. I think some of us could benefit from some more bed mass practice. But yeah, we'll see how she goes. The test is going to be next week. We have no school Friday. It's going to be next week Thursday. Next weekend there is a 4-day weekend for you guys, which is pretty fun. Okay, yes, I suppose if you wanted to play Fortnite, you can play Fortnite. Do I play Fortnite? No, I absolutely don't. Okay, so here we go. With negatives, sometimes the continued issue with negatives, sometimes we drop them entirely, sometimes we don't know what to do with them. This lesson is just reviewing what happens and how a negative impacts a fraction. So looking at these first 3 examples here, it doesn't actually matter where you choose to put the negative. Whether it's out front here, whether it's in the numerator here, or whether you choose to put it in the denominator here, each one of these fractions is the same. What this one says is, because a fraction is just division, right? That's what I'm trying to get you guys comfortable with. A fraction taking or throwing down a fraction just means I could divide this, but I haven't yet. So 1 over 2 is the same thing as 1 divided by 2. You guys would know that if we converted that to a decimal. Oliver, do I have to move you already? Okay, stop talking then. 1 over 2 is 0.5. And then I would just add the negative to it. It would be negative 0.5 if I did the division. It would be 1 divided by 2, and I make the thing negative. This one would just be negative 1 divided by 2. Well, negative 1 divided by 2, when you take a negative number divided by a positive, that result is going to be negative, and then 1 divided by 2 is still 0.5. 1 divided by negative 2 is exactly the same. Now the 1's positive, but the 2 is negative. When you divide a positive by a negative, your end result is still going to be negative, and 1 over 2 is still a half, or 0.5. So it doesn't matter where it is in the fraction, it's going to give you the same result either way. There is one of these you will almost never see. The first 2 are what we consider mathematically conventional. What I mean by mathematically conventional, well, when something is conventional, it follows the rules outlined by the people who get to make those decisions. So mathematicians somewhere said, this is how it's going to be. A bunch of other mathematicians said, we think that's a great idea. They all voted on it. You and I don't get a say because you and I aren't qualified to have an opinion. Notice how I lumped myself in there too. I'm not good enough at math to be able to have opinions about how it should be written. Even though I'm pretty good, I don't hold a candle to the guys who actually make the decisions. So they're like, yeah, this, and y'all are going to like it. So that's cool. I'm fine with that. This you will never see unless I create questions just to see if you guys are comfortable with it. In standard mathematics, you will almost never see this. Negative signs will usually get absorbed into the numerator, or they'll get written out front. This you will almost never see unless someone is trying to, just throw it at you to see what you'll do with it, like I may do. It's important for you to recognize they're all the same. This one is not a common way to write it. So, does the position of the negative sign matter? No. It does not, as long as you've only got one of them. Because what happens when you have two of them? Sorry? It'll be positive. If you've got two of them, if they're both negative, I've got -1 over -2, it's just like multiplication. When you're multiplying two negatives, your result is going to be positive for reasons I showed you last week. I had the picture with Pac-Man. We treated one number as the direction he was moving and the other as the direction he was facing. When you multiply a negative by a negative, the end result is positive. Same thing with division. This is going to give us 1 over 2, and the whole thing is going to end up being positive because these two things are going to cancel. So otherwise, things are exactly the same. Generally, when you do these things, you want to keep the negatives with the numerator as far as the math goes. So like if I had two fractions like this, if it was 3/5 minus 2 over 5, the way you would treat this thing is if it was, because the denominator is actually already the same, and we've done some of these already, we've already subtracted fractions, but just so we're really clear what's happening here, when the denominator is the same, it's going to become 3 minus 2 over 5. We're not subtracting denominators. I've seen students do this where they're like, ah yes, 3/5 minus 2/5 is 1 over 0. No, remember, the denominator you leave alone, and with the operation when you're adding or subtraction, it gets brought up into the numerator. So 3 minus 2 is exactly what you'd expect it to be. It's going to be 1 over 5. Things get a little bit more interesting when we make one of them negative, and then so like I've got -1 over 2 minus 3 over 4. It behaves the same way the integers did before. When I'm subtracting fractions, we need to do what? What's important about subtracting fractions? Agershan? We need a common denominator, so the smallest number that 2 and 4 can both go into is 4. So to make this fraction go into 4, I'm going to multiply the top and bottom by 2. So my question is then going to become -2 over 4 minus 3 over 4. So that thing is going to become -2 minus 3 all over 4. And I treat the numerator the same way we've been treating numerators. If you need to use the number line, use the number line. I'm at -2, and I'm taking away 3. So which way would I be moving if you're picturing a number line in your head? Careful. If I'm at -2, let's draw the number line out. 0, -1, -2, and I see earbuds in ears. You guys take your headphones out. You shouldn't be on your phones. We're listening to music even right now. Headphones need to go away. I'm here at -2, and I'm subtracting a +3. So which way am I moving on this number line? Left or right? Is it going to be getting more negative, or is it going to get positive? Andrew, I see gears turning. Do you have a thought? No? You know, just so I'm fair, let's toss both ends of the number line. If I'm at -2 and I'm taking something away, whenever you take something away and that thing you're taking away is positive, like when I read it, I didn't say I was taking away a -3. I'm just taking away 3. When you take away 3, you're going to become more negative. So I'm going to end up moving this thing to the left. I'm going to go 1, 2, 3 to the left. So -2 minus 3 is going to become -5 over 4. This is going to move this way 3 because I'm subtracting a positive. Likewise, I could set up something like this. If I've got -1 over 2 minus -1 over 3, I need to make sure that when I'm dealing with subtraction or addition, that my denominators are the same. Jackson, you writing stuff down with us? My denominators need to be the same. What is a number that 2 and 3 both go into? 6. It's not the only one I could use. I could use any number that they go into. 6 happens to be the smallest. So if I want to turn these denominators into 6, I'm going to multiply this guy by 2 and this guy by 3. And whatever I do to the denominator, I also have to do to the numerator. So this is going to be times 3 times 3. This one's going to be times 2 times 2. It's going to change our question. Our question is going to become negative 3 because it's negative 1 times 3. Don't drop the minus sign. Over 6 minus negative 1 times 2 is negative 2. Don't drop the minus sign. 3 times 2 is 6. And now what I'm actually doing here is dealing with this in the numerator, and I'm leaving my denominator alone. So what's happening is I'm going to get negative 3 minus a negative 2 all over 6. When I've got that double negative there, when I'm subtracting a negative, what's actually happening? It's becoming positive. When you take away something negative, you become more positive. You're not going to become totally positive, because if I'm at negative 3 and I'm subtracting negative 2, is that enough to bring me positive? No. What's it going to bring me to, Jackson? It's going to bring me up to negative 1. I'm at negative 3. I'm adding 2. I can use this number line. I'm going to go this way too. I still haven't broken the negatives, but I'm less negative than I was. So this is going to become negative 1 over 6. How you handle negatives, especially now that as we've seen on this quiz you guys wrote for me, are really, really important. Okay, slide down here. Multiplication. Multiplication and division is a lot more forgiving. It doesn't matter where you place the negative sign. That is true. Conventionally, it's best to include with the numerator, which is really only going to impact you when you're flipping things, which only happens when you divide. So this second one here we're going to see in a second. I got negative 2 times a third. So when this was stuff we did yesterday, when I'm multiplying a whole number by a fraction, what do I have to do to the whole number? Sorry? I had to put over 1. And then I just multiply across the top. I multiply across the bottom. It's nice and easy. Negative 2 times 1 is negative 2. 1 times 3 is 3. And we're finished. There's nothing fancy or special there. I'm going to add another question in here. What if it was this? Negative 2 times negative 1 over 3. I'd still put this over 1. The only thing that's going to change here is what? That's still going to be a 3. 1 times 1 is 3. Yeah, these two negatives are going to make it positive. Negative 2 times negative 1 is going to become positive 2. You don't have to put the plus sign in there. I'm just putting it in there to emphasize the fact that this is going to be positive 2. I think I really only got one more today. Well, and then we're going to look at BEDMAS examples. I'll give you some time to work on the back page. But we are going to do the BEDMAS lesson today as well. So then this guy, I've got negative a half divided by negative a quarter. And look at how it's written. This one's got the minus sign kind of in the middle, in line with the line, and this one's got it obviously in the numerator. Best practice, because you're already doing it with addition and subtraction, it makes sense to do it here too. It's best to include with the numerator. It doesn't matter if you flip the fractions, leave the negative sign in the numerator. That's the whole argument I was trying to make up here. It doesn't matter where the negative sign ends up, but I see students make mistakes when it's anywhere other than the numerator. So this says you're allowed to leave it in the numerator. So what we're going to do here is this thing is going to, that negative 1 over 2, I'm going to bring it up into the numerator. I'm going to absorb it into that. So this thing's going to become negative 1 over 2. Because I'm dividing by a fraction, what do? What's the technique? And we're going to flip this thing. When we flip it, because it doesn't matter where the negative sign is in the fraction, leave it in the numerator. So negative 1 over 4 is going to become negative 4 over 1. And then negative 1 times negative 4 is 4. 2 times 1 is 2. And now I've got to simplify this thing. 4 over 2 is just going to be 2. If for whatever reason, I'm going to drop down here. If for whatever reason you're like, no, I'm going to do whatever I want to do. I'm not going to leave it up there. When I flip this thing, I'm going to bring it down with me. This is the only thing that's going to change. The question is going to become negative 1 over 2. If you bring the minus sign down with the negative 1, you're going to end up multiplying by 4 over negative 1. At this stage, what you need to remember is, well, one of two things. Either, we're going to branch this one off too. Either you're going to multiply negative 1 and 4 and get negative 4, and then 2 times negative 1 is negative 2. And then you have to remember that a negative divided by a negative is a positive. Or, there's another option here. When we're multiplying fractions, what do we always want to consider looking for? I heard someone whisper it. Any simplifications? Whether we can cross simplify or whether we can vertically simplify. Is there any vertical simplifications we can make here? No. But we can cross simplify two things. We can cross simplify these negative ones. They're the same thing. These can be cross simplified. Negative 1 and negative 1, it's going to cancel out. It's going to give me 1, because negative 1 divided by negative 1 is 1. And then this thing can cross simplify this way. I can divide both of these by 2. It's going to leave us with, if we're going to write it all out painfully, 1 over 1 times 2 over 1, which is just 2. I get the same thing. It doesn't matter how you think about it or how you approach it. You're going to get the same result as long as what you're doing is mathematically permissible. I have students who occasionally like to make up new math. Don't make up new math, especially here. There really is not a lot of new math here. That's it. I want to get you guys comfortable with some negatives, so I want you to flip the page. I am going to give you, how much time should I give you? There's 16 questions. I'm going to give you till you've got a short lesson tomorrow, a short day tomorrow. Yeah, tomorrow's a SLO day, so you guys start late and you only have an hour-long block. I want you to do all of these, and we'll see where you guys are at 10:30. On your market, set, go. 25 minutes. I'm going to pause the recording, and then we'll pick it up in a little bit.